Right then. Well, good afternoon, everyone. I hope you have all had a great day. The topic of today's workshop is laboratory safety and prevention, imparted by myself, Ricardo Sainz. I am a Bachelor of Science in Chemistry graduated from the University of Texas at El Paso. These workshops are designed in a maximum time of 1 hour under the premise of robustly covering technical topics and sharing experiences in specific topics. They are oriented towards particular topics, which is why we cordially invite you to follow us and stay up to date on new workshops on our social media. Supporting those who follow us, we provide a verification of assistance for leaving in the comments your full name, professional formation, and email. Before we begin the workshop, we will be discussing the agenda and structure of such. First, I will be introducing EPS and the services we provide, followed by defining the objectives we seek to fulfill with this discussion. Beginning the workshop, we will be discussing the normatives and regulations that apply to laboratory safety, labware, responsible lab conduct, and some examples of accidents that have happened in laboratories. The function of EPS is to professionally attend the project qualification, validation, and training needs in industries and organizations in health sciences and research at a global scale to accomplish the following of the corresponding regulatory standards, such as COFEPRIS, FDA, INIMA, among others. By the end of this workshop, the objectives we would have would be to know the proper personal equipment for laboratory safety, being able to apply responsible lab conduct and lab organization to minimize risk of accidents, and know what actions to take in the case of emergencies. The information in this workshop is based on the following guidelines and normatives: the EHS guidelines, Hazmat guidelines, and the Mexican norm NOM 059 SSA1 2015. The EHS guidelines offer the following core purposes of laboratory safety and prevention: eliminating the hazard by removing the activity from the work process. Examples of this include substitution with less hazardous chemicals, using different manufacturing processes, etc. Controlling the hazard at its source through use of engineering controls. Minimizing the hazard through design of safe work systems and administrative or institutional control measures. Providing appropriate personal protective equipment in conjunction with training, use, and maintenance of the PPE. The Hazmat guidelines are issued by the U.S. Department of Transportation to regulate the transport of substances that pose an unreasonable danger to the populace or environment. The term includes the following: hazardous substances, hazardous wastes, marine pollutants, and elevated temperature materials. And these can be further classified into explosives, gases, flammable liquids, flammable solids, oxidizing substances, poisonous and/or infectious substances, radioactive material, corrosives, and miscellaneous dangerous goods. Later on in the presentation, we'll be discussing some examples about how being aware of different hazardous substances can change the outcome of a laboratory accident. And we will also discuss regarding the regulation about replacing extremely hazardous materials with less hazardous alternatives. We'll be looking into an example of that as well. So about the Mexican norm NOM 059 SSA 1 2015, this norm usually regulates the proper production of medicines. Here we'll be applying the principles that apply to laboratory safety. Good laboratory practice, as defined by this norm, is the conjunction of rules, operational procedures, and established practices to ensure the quality and integrity of the activities realized in the laboratory and the analytical data obtained from tests or experiments. It also tells us personnel working in environments with risk of contamination, such as sterile zones or environments with highly active, toxic, or infectious substances, must receive specific training. Personnel must wear clean and adequate clothes for the activity they will realize, with the necessary characteristics for the protection of the personnel and the product. Right, so getting into the workshop proper. In laboratories that employ chemicals, we usually see defined safety wear to protect workers from any chemical or physical injury. So here on the right we see a caricature of a laboratory worker. He has his goggles on, the lab coat, and we'll imagine that he has some gloves on. These are the principal lab wear that we use for endorsing the safety of our workers and also the quality of the work being done in the laboratory. In laboratories, lab coats are used to protect against accidental chemical spills, such as acids or other irritants that may be used. They are usually made of an absorbent material, such as cotton or polyester, to protect the user from said chemicals. In the case of laboratories using pyrophoric chemicals, it is strongly advisable to use flame-resistant lab coats. By pyrophoric here, we will understand substances that spontaneously ignite when in contact with air. So, about safety goggles. Safety goggles are meant to protect the eyes from any chemical or biological material that may cause significant injury. It is recommended by several occupational health organisms to use the enclosed goggles rather than frame ones. The reason why several organizations would recommend the top enclosed goggles is because they provide a much safer protection, being that they are enclosed in the bottom. In a situation, for example, where you would be trying to dissolve acid and some of the acid could sprinkle onto your face, the enclosed goggles would be able to protect you while the framed ones wouldn't be able to. Nitrile gloves are usually used for everyday lab work as they are chemically resistant and are a necessity to limit contamination in laboratories that require high sterility, such as biological labs or synthesis of nanoparticles. It is to be noted, although nitrile gloves are efficient for everyday work, there are certainly chemicals that can filter through nitrile gloves. Later on, we'll talk about an example where a chemist was using the improper type of gloves and the chemical she was working with completely permeated through the glove she was using, so it provided no protection at all. So it is very important to be aware of what kind of jobs are best suited to the job. There are many procedures and conducts which can be taken in laboratories to minimize risk of accidents and ensure a safer environment. So, in my opinion, the most important conduct you could have in the lab is being able to know exactly what materials or chemicals you'll be using and how to best be prepared for handling them. The best way to know the chemicals you're working with is to check an MSDS sheet, which will have all the information you could want to know about the health hazard a chemical may impose. MSDS sheets are usually found for any chemical you could use in a lab, and you can look them up online or in a manual. There's also the health triangle, which we could see here on the right. The health triangle can give us information about health hazards, fire, and reactivity, as well as specific hazards a chemical may have, such as being an oxidizer, an acid, or having radiation. If you are aware you may be working with or are around dangerous reagents, you should be accompanied by coworkers in the room. No matter how many times you've done an experiment, accidents can happen at any moment. So the most important thing here is to never overestimate the dangers that chemicals can pose in a laboratory. You may say that boiling sulfuric acid. I've done it several times in my times as a laboratorist, but I still wouldn't trust myself to be able to survey this experiment alone when I know that sulfuric acid is easily a very dangerous chemical that can cause severe burns, and even its vapors can cause severe damage to you. An organized lab is a safer lab. So here we can talk not only about the safety improvements of having the lab organized, but also it makes workflow a lot easier when you can be able to know where every acid or every solvent is in the lab. By an organized lab, we would mean that solvents should be stored with other solvents, acids with other acids, and all hydrophilic materials should be stored in a dry cabinet, and so on. It's according to their purpose and according to what metal they might be. There's very several ways of being able to organize how a lab can be structured. The first thing that should be done when beginning to work in a lab should be to familiarize oneself with the safety measures set in place in such. The most common safety measures in labs are safety showers and eye washes. Both serve the purpose of washing someone that has come into contact with hazardous substances. In the case of an eye infection, it's advised to wash eyes in the eye wash for around 15 minutes. Fume hoods are an essential part of any laboratory. These have the purpose of limiting exposure to toxic or hazardous fumes. In addition, fume hoods can also protect the user from explosions and contain spills made in them. In the image below, we see a glove box. These can be considered an even more secure fume hood as they minimize the contact a worker could have with the reaction. It is ideal for working with pyrophoric or highly reactive substances, as the enclosed box can be put under noble gas atmosphere and controlled temperature. Laboratories that count with eye washes should also verify their correct functionality at least once a week so as not to risk an incorrect functionality when they are needed. In the past laboratory I was in, there was a checklist, for example, of who was going to test the eye washes and showers every week. So it was rotary and it had to be done every week because the environmental health services in our university required it of us. It is also important to keep fume hoods or glove boxes constantly validated, as a malfunction of these has the potential of contaminating a room with toxic fumes. Proper procedure in case of accidents. Workers in a lab should be informed of the proper procedure to follow in the case of accidents and who to contact in such cases. As examples, it would be recommended for a laboratory specializing in toxic heavy metals to have the phone for a toxicology clinic at hand, one that has pyrophoric materials to have a contact with a severe burns clinic, or etc. So this is the last part of the presentation where we will be discussing accidents in laboratories and how they could have been avoided. So the first case we're going to talk about here. Karen Wetterhand was a very respected researcher in her field. She had published more than 80 papers, many on how the body would metabolize heavy metals and how they could cause cancer, and funded programs to incentivize young women in science fields. Dr. Wetterhand was pipetting a small amount of dimethylmercury under a fume hood when she accidentally spilled some on her latex glove. Following safety protocol, she immediately washed her hands and cleaned her tools. However, a few months later, Dr. Wetterhand began showing symptoms of mercury poisoning and was interned in a hospital. The mercury level in her blood was too high, and in June 1997 she passed away. So what went wrong here with this first case? Well, at the time of Dr. Wetterhand's accident, people still weren't aware of the toxic properties of dimethylmercury. It was of course known that mercury compounds tended to be toxic, but not much research was done on the health hazards regarding dimethylmercury. After Dr. Wetterhand had passed away, some of her colleagues had given themselves the task of researching dimethylmercury and what could have happened that caused her death. So their studies found that dimethylmercury actually permeates many types of plastics and rubbers, including latex. So in this occasion, the gloves that were in use by Dr. Wetterhand were unknowingly inadequate for the handling of this chemical. So today, what would be the proper procedure for handling dimethylmercury? For the handling of dimethylmercury, today we have specialized highly resistant laminated gloves. Although in reality, dimethylmercury has been phased out of the industry and research labs, as many other reagents or less toxic options have been opted for the study of mercury compounds and the other uses that dimethylmercury had. So the case of Sherry Sanji. Sherry Sanji was a 23-year-old research associate that had recently graduated from University of California at Los Angeles. She was using a plastic syringe to transfer a compound called tert-butyllithium, shortened. However, the syringe Sanji was using fell apart, spilling the chemical and igniting a fire. Due to not wearing a lab coat, Sanji's clothes had caught fire. The postdoctoral assistants left their own experiments to try helping her and called the professor in charge of the lab and 911. Sanji was transferred to a hospital with severe burns and was being treated. Unfortunately, her organs had begun to fail and she passed away 18 days later. So what went wrong here? Well, tert-butyllithium is a very hazardous material. As we had mentioned before, it's pyrophoric, meaning that it will ignite spontaneously when in contact with air. So there's many things that went wrong here and many reasons why this accident happened. So the first reason is that Sanji should have been wearing a fire resistance lab coat in this occasion because she was dealing with a very flammable material. And substances with very dangerous properties, such as pyrophoricity, should not be worked alone. I mentioned earlier that she had postdoctoral assistants with her in the research lab. However, these assistants were not supervising her experiment. They were actually doing their own experiments at the time. And it was only until the accident had happened that they were aware that something needed to be done. And this experiment should have been performed in a glove box with noble gas atmosphere. So, were this experiment performed in a glove box with a noble gas atmosphere, tert butyl lithium would not have been able to react violently as it is inert with noble gases, such as noble gases tend to not have high reactivity with any compound. And there was actually a very long standing legal case between environmental health agencies and the University of California at LA and the teacher that Sanji was under, where Sanji's superior, her teacher, tried to argue that she had done this experiment many times before and it was all an accident and not at all a case of neglect, which he was being accused of. The courts, of course, had found him guilty of this neglect that he had done in his laboratory, as he had been accused several times before of not having the proper safety regulations in his lab. And this goes back to what I was talking about earlier, where as many times as you've done an experiment, it's it's always good to be supervised when you're working with highly reagent activital with highly reactive reagents, apologies. So this argument where Sanjay's professor attempted to explain that it was all an accident and she had done the experiment many times before, it didn't hold water at all because, right, you shouldn't be able to do an experiment like that unsupervised. Well, I appreciate your attention. This is the end of the presentation. If you have any questions or comments, please leave them in the chat and I will do my best to respond. All right. Well, thank you a lot for coming. I appreciate your attention.